So our lunch presentation is Vinod Khosla. Vinod is a venture capitalist. He was a co-founder of Sun Microsystems and the first president and CEO. Then he was a general partner at Kleiner Perkins, a venture capital firm, and then his own company, his own venture firm, Khosla Ventures. He is, just as an interesting note, in the first paper, that first example that was raised in Scott and Rebecca and Ian's paper of Atomwise, that was a graduate student that came from Toronto but couldn't get financed in Canada, and so got on a plane and went to the Bay. And Vinod was an AI to basically predict binding affinity between proteins and molecules for drug discovery, and Vinod financed his business along with many others. So why he was such a great choice for us for our lunch conversation is he is one of the most prolific investors, he and his partners at his firm, in artificial intelligence. And so he's going to talk to us about how he thinks about AI and how he makes his capital allocation decisions with his vision of how this is unfolding.
Great. So my goal today is not to leave specific points with you, but the impression that something large is happening, and it has many more implications than people realize. The fundamental discussions around causality in models, all that, will be laid relatively irrelevant in my view because the large structural changes we'll see driven by this technology. So it's more about impressions. It's a whirlwind tour. It's much more about speculation. It's much more about asking you to keep your antennas up for something completely orthogonal and different. So that's my goal today, but I'll put it in the context of the topic here, the implications in economics of AI. I started with the top 20 job categories in the United States. And I asked the question, for at least 15 of the 20, do I believe there is more than a 50% displacement of current employment within some period of time? And I'll come back to that. And the answer was clearly yes. And it's happened before. The yellow line is employment in agriculture. Industrial employment is the blue line. It's starting to go a different way. And I wrote about it first when I was mostly very fuzzy in 2014. And I said, we'll have great GDP growth, great productivity growth, all the things economists like to matter, and increasing income disparity at a level where it will render traditional economics largely irrelevant. Capitalism as by permission of democracy, in my view, and when democracy doesn't work for most people, we'll see large changes. And I want you to keep this idea of going from a wind to a hurricane or from a wave to a tsunami in mind. In the next 10 or 20 years, most of the jobs, that is well north of 50%, we can speculate how much, will become replaceable, even though they're not yet replaced, because diffusion takes a while. And this is much more fundamental than even the notion of a general purpose technology, in my view. So let me start by a couple of areas, and I'll go through this very, very quickly. This is a company that John Deere just bought last year that weeds fields. If it weeds fields, it changes the nature of agriculture and lead to every plant in a million plant field being treated differently. It completely upends the need for herbicides or insecticides. This company building assembly line robots. That's a large part of employment. And whether these companies work or not, somebody will work in this area in the next 10 to 20 years. Then they're more illustrative than meant to be. This will succeed. Amazon, of course, trying to do retail workerless grocery stores. Other companies are working on the same. Retail workers subject to this trend. Janitors, this company is doing robots that sort of clean in this case, grocery stores, evening cleaning, without janitors. This is a company that replaces all of a McDonald's, about 150 burgers an hour capacity, with no workers. Everything from slicing fresh onions to tomatoes to customizing the hamburger, even grinding the meat. This is delivery on the streets, delivery workers. This is warehouse workers. And I'm not trying to give you the details of any. I want to leave as much time for questions as possible. This is security guards patrolling. Driverless cars that replace taxi drivers and Uber drivers, truck drivers. These things are closer than most people believe. This will happen in the next 3 years, especially since most of the truck driving happens on freeways. That's a simpler problem. It's a few years away. Customer support reps being replaced with AI dialogue systems, and only the 10% of most difficult cases being escalated to humans. We can come back to the role of humans, but human AI systems will be important, but it'll be 90% less humans. Even business process, automation, trade finance, compliance filings, all that sort of backroom work in finance. Security analysts for cybersecurity. Stock trading, of course, we know the yellow line is the quant trading that doesn't need traders. In fact, there was a statistic I saw, Goldman Sachs in the year 2000 had 600 traders. They now have 2 in this particular area, 600 to 2. That'll be very typical. This is forensic accountants. Even legal workers. Law should be done with an AI system because it's a structured language. In fact, there's only a certain number of laws and only 7 million cases interpreting all those laws, whether it's real estate or employment law. It is relatively simple in this context to do, and Jan can talk about the progress in natural language processing. Healthcare, I'm very excited about. I see no reason to ever consult a human being in medicine in the next 15 years, after the next 15 years. Just no reason to have a doctor. Radiologists, clearly, this service is now being offered to do radiology reads. And this is one of those important points. It isn't about more education because the highest skill jobs may be the easiest to replace. Radiologists, this radiology reads are now being offered for $1 per read, and it happens in minutes, not 3 days, as happens with an MRI scan today. This company, with a $99 device you can buy on Amazon called the LiveCore device, or a watch band for the Apple Watch, will essentially build personal neural net models, tell you way more and understand way more about your heart than a cardiologist possibly can, because it considers hundreds of variables. And this is now a $10 a month service to monitor conditions like atrial fibrillation. I have to be careful. We are certain things are FDA approved and certain aren't. Drug discovery, Atomwise is one of those companies. Deep Genomics, another Toronto company, discovering a new class of drugs. There's no amount of effort with traditional drug discovery that can keep up with this scale, because you're talking about 10 to the 3, 10 to the 4 orders of magnitude improvement in the capability to discover drugs. This particular company is not only interpreting your ultrasounds. Cardiac MRIs, ultrasounds are really hard. You need specialized technicians. It replaces the technician and the cardiologist who reads the ultrasound. This is my favorite, psychiatrist. Somebody was talking about facial expressions. This thing can predict when a bipolar episode's coming on by just the data on your phone. Milliseconds you take to respond to a text message, where you spend your time at home, when you get out of bed, whether you go to the dining room for dinner without you ever opening the app. Diagnosticians, so healthcare, it's hard to see. Now, there's interventional medicine like surgery, but even that is becoming more roboticized. I wrote this, the second piece I wrote in 2012, that was 6 years ago when things were very fuzzy. The other piece speculates that almost all of medicine will be without people other than the human element of care. I actually got laughed at because 3 years ago I suggested to the dean of Howard Medical School that they ought to change their admissions criteria to be the same as the USC Film School, because they were selecting for IQ and they needed to select for EQ. And then there's lots of clumsy stuff that's happening that I'll just mention in passing. Personal robots. Alexa is a robot. It's a new interface, still very clumsy. I don't consider it real yet. Agronomy. You don't need agronomists. And you can do much better and more often with every plant. Even food is being designed with machine learning. So this particular company, Hampton Creek, has a mayo you can buy at Whole Foods or Lucky's or your favorite Kroger's or your favorite local grocery store. If you buy just mayo, they have tens of thousands of proteins characterized with their properties that they use to design new products that are designed with machine learning. This construction robot can lay bricks 6 times faster than a human can, laying bricks. This is one of my favorites. This is a Boston Dynamics robot. Let me see if I can click on this. Oh, no, sorry. Let me go back. I'll skip that. This robot can do things humans can't. This is a helicopter that taught itself aerial maneuvers, things humans couldn't possibly do because they can't respond fast enough to the capabilities of a current machine. This is another one of my favorites. Machine learning used to teach judges with higher accuracy when parole is warranted, because they can analyze behavior better. This is a company that builds software that optimizes software. So you can optimize a website without humans. A/B testing, IT operations, translation. Of course, robots with guns. They come back to this issue of autonomous weapon systems. And then there's new domains that are not human domains. And these are all the reasons I think economic life will change so much. Google search is now significant component is starting to be AI, not traditional techniques. Even coming up with algorithms, and there's this notion that somehow the creative tasks are for humans, algorithms that machines are designing for video compression. Optimizing the power consumption of data centers. Google had a data center. They're the best optimized data centers because power is a huge cost. Human optimized data centers were, and a human might do really well with a 1 or 2% improvement in power consumption. This machine learning algorithm in an already optimized data center did 25 to 40% depending upon how you measure it. Of course, faces are being used for all kinds of things. The Economist, this is a recent cover from The Economist. Then the other question, can machines be creative? And there's no question in my mind machines can be a lot more creative than human beings. Go was, of course, an example, and that was not even a lot of very creative data science. It was taking a couple of existing techniques and putting them together. But as judged by the human opponents, the machine had way more intuition than the Go players. That was the quote from the opponents, human opponents who are experts in Go. Way more intuition, not intelligence, not more search space. This is another one of my favorites. That painting above was submitted to a system to paint that painting in a different style. You can take any photograph or any painting and paint it in a different style. So painting, This is maybe my most famous thing. This is, I bought off Haiku off Amazon last week, all 3 pieces. On the right bottom is a book on digital art done by a machine. On the left, a book of haiku done by a machine entirely. You can buy all 3 on Amazon. And classical music composed, this was a CD I bought, by a machine that passed the following test. A classical music professor objected to the notion that a machine could design. So they mixed 3 pieces, 6 pieces from Bach himself, 6 pieces designed by the computer, and 6 pieces designed by this classical music professor. And an independent panel in a blind test was asked to judge which was human, which was not. Interestingly, the machine was judged as more complex and more nuanced, and obviously original Bach. Bach was judged as the music professor, and the algorithm, what was judged to be algorithm's music, was really the professor. So this hopefully answers this question. But there's way more. This is inventing new instruments by combining the spectral qualities of existing instruments to allow more tools for more creative things. And as the complexity increases, humans won't be able to leverage them, but machines will. So better music. So let me talk about the new dimensions of AI. Where we roughly are is that little yellow and red Lego block thing in AI today, because we have a few components like were put together in AlphaGo. What we will see is the ability to build a Sydney Opera House out of Lego pieces as the numbers explode. What are some of these pieces? And dinner, you'll hear more about these. But GANs, I won't go through what these are, but just to tell you that a lot more is possible. Probabilistic programming, how do machines learn as fast as humans do, unsupervised learning, reinforcement learning. I won't go through any of these because there's not enough time. I just want to convey the impression there's a dozen new things that are being experimented with, and some will be more valuable than others. Even learning to learn was a recent paper out of Google research. So, and this is without the tools to turbocharge this research. And that's happening too. The number of the best data scientists, graduate students in the world going into data science is one of the biggest turbochargers. It's always about where the best PhD students are going, and this is where they're going. It's custom hardware being designed to accelerate these experiments. It's much more data becoming available. It's about open source research. It's about tools made so everybody at every level can start to play with these and look at new applications. And they really help define the problem, because I don't believe in AI we've actually defined the problem fully yet. Of course, quantum computing would be a game changer potentially. I just met with a company this morning saying we'll specifically and narrowly address one problem of AI learning. So let me talk about the potential impact. I think the traditional notion of labor and capital will change very dramatically. Labor, of course, will be devalued. Traditional situations like more education won't work. When machines exceed human capability, the old correlation with new technology creates new jobs and new opportunities, which is much more correlation than causation, will die because the assumptions have changed enough, in my view. In fact, it's not clear whether even capital will be as important as ideas. So I call it an economy of labor, capital, and ideas are becoming way more important. It's not incidental that you see so many new billionaires being minted on individual ideas. It has changed the relationship between labor and capital very quickly, and things like education. And if everybody can live like a king, because if I'm right and productivity goes through the roof over 50 years, and I'd like to emphasize timing is very hard to predict. So it's all speculation. I couldn't tell you whether it's 20 years or 50. Where do you find meaning in life? I think that and income disparity would be the biggest issue. We will have lots of possibilities. I always say Kickstarter is an indicator of new jobs being created in the traditional economic sense, or America's Got Talent, if you want to call that a job, or X Games, or pick your favorite. Maybe there's an emotional role for humans, even if machines do emotion better than humans. Maybe there's a role. Let me switch to a different topic, something much more immediate. And those of you interested, I wrote a blog on Medium last night. I think AI changes national defense, national security, and geopolitics very, very dramatically. That may disrupt trust, which may disrupt the economy in very unusual ways that we haven't thought about yet, and that we should. There's a lot of talk of sentient AI and AI going rogue. I think this is an order of magnitude bigger problem in the next decade. And if Putin had these tools, just hacking emails would be trivial compared to everything else you can do to cause disruption. Those of you interested, this blog was just posted last night. I think it's the equivalent of a nation state or a criminal entity being able to be the only ones with the atomic bomb. And we know what happened when we exploded the bomb in Hiroshima. There was very little choice for the Japanese. That situation can happen in a much worse way. I also want to just leave a little sense. This is progress in image recognition. And the line at the bottom is the error rate for humans. And you can see systems have gotten much better. What I'm most interested in is comprehension. This is comprehension on a children's book. And you can see where this is going. And the dinner panel would talk about it much more authoritatively on where it can go. But you can imagine it exceeding human competence very quickly. We tend to not believe in change. In '85, I had these discussions, and I was told, can't imagine a PC in every home. I think that's right. You can only imagine 1,000 PCs in every home today. 1990, I was actually laughed at for having my email on my business card in 1982. But by 1990, grandma was with email, and it wasn't imaginable. 1995, AT&T told me they would never adapt TCP/IP when we started a company called Juniper. Because of that, by the way, Juniper was the highest ever venture return, a $2,500 multiple. Kleiner Perkins, where I was then, made $7 billion in profit on a $5 million investment. But you can go on and on. There's all these assumptions. So let me stop there and open it up to questions.
Great, thanks, Vinod. There's also mics so everyone can hear.
Vinod, I tried to set high expectations for your talk, and you exceeded them. That was really splendid. I am sympathetic to the basic thrust of your talk, and in particular, the thrusts that went to large-scale labor replacement. Here's a fact. I think it's a fact that puzzles me. I've spoken to I've tried to do this a little bit myself, and I've spoken to a number of labor economists. And in the spirit of demonstrating what you're saying, I looked at data on occupations, and my idea was that we would see now more destruction of occupations than we've seen traditionally. So my idea was, if you sort of said, what fraction of the occupations shrink by, or what fraction of the people are in occupations that shrink by more than a third over a 5-year period? I expected that those numbers would be higher now than they have been through most of time. I've not been successful when basically I believed what you said and I was trying to torture the data to demonstrate what I believed. I have not, and I've asked others, you can't look at data on occupations and find a higher rate of occupational churn than the kind of historical norm, which is pretty high. You know, it turns out that there used to be huge numbers of people typing things because there didn't exist Xerox machines. And so this idea of a new, faster rate. So I guess my question would be, you live it and you see it, but I think my method is not an unreasonable one. And I think it doesn't bear out this belief of yours, which I'm inclined to share. And we kind of believe in empirical science. So I guess I'd be interested in your reaction to that puzzle.
So I've seen the argument, I've heard the argument, I don't buy it. What you call causality is really an extrapolation of the past. And it works as long as that extrapolation is unimportant. The only time it's important is when radical change happens, when assumptions change. This field is so new, it can't possibly show up in the data. Facebook AI research, Jan and I were talking last night, was started 3.5 years ago. Right? This field didn't exist. The turbochargers aren't there. They haven't reached the level of maturity to go through the 5 iterations of any technology it takes to get to the level where it can be widely deployed. Yes, we will prove these jobs are replaceable, not that they're replaced. So I'm saying.
So yours is fair. So let me just make sure I got it. You're saying, who knows whether the internet was bigger than the destruction of agriculture? Maybe it was, maybe it wasn't. But you're very confident that AI is truly transformative relative to everything before, and it hasn't been going for 20 years, so there's nothing to look at. And you'd probably say that if 10 years from now I was able to do some occupation calculation and found that there hadn't been more occupation destruction, whether there was new creation or not, if there hadn't been more occupation destruction over the next 10 years than there had been historically, then you'd probably say you'd gotten something wrong. Or maybe you just gotten the timing wrong.
I'd agree with that. I'd go a little bit further. In the next 10 years, I want to prove that of the top 20 categories, the majority of the jobs become replaceable. Because I think the model you'll see is economic deployment whenever one of these technologies can cut the labor content in half. If United Healthcare can take 10,000 of its claims processing experts and replace them with AI system plus 5,000, that's when these technologies will get deployed, because there's a barrier to change in large institutions. Then once you get to that 10,000 goes to 5,000, you'll see annual increases, reductions at a certain rate. So I'm saying what we should be watching for is in the fringes, because all systems change at the edges, not at the center. And there, it doesn't show up in historical data because it's such a small point. Just the change from an industrial economy to a service economy is a much larger change, which is still going on, than this technology change would intuit, and I think it'll get lost in the noise. So one has to fundamentally look at what's going on and where the exponential may lead. So you're doing more of a linear extrapolation. I'm saying this is an exponential phenomenon. Yes?
Thank you. So on the last point you made regarding these barriers to shifting, I'm wondering if one of the implications of that is that companies like, I have 10,000 claims processors, I'm going to need something that is going to mix between before I could shift. Does that suggest, or do you think it suggests that a lot of the change is going to come from entrants who are early on adopting these new technologies, disrupting business, and making incumbents go out of business? Or do you think that incumbents will be able to adopt despite these barriers to adoption?
So my experience with technology has been large institutions almost never innovate. In fact, I went through the exercise. I have a separate paper I'm doing on finding an innovation, where innovation comes from. In the last 25 years, I couldn't find one material innovation that came from a company this group would consider relevant, whether it's GE or Siemens or Bank of America or IBM. They're largely relevant and, in our world, non-technology companies with technology veneers. And I'm happy to go into the detailed discussion of that. But let me just put it the following way. Did Volkswagen or General Motors innovate cars, or did Tesla and then Waymo, which wasn't in the business? And by the way, that change, because of its, if you follow it through, will likely replace public transportation, in my view. Public transportation will be replaced. It'll be $1 to go from anywhere in the city to anywhere else, point to point, or dispatch service. That's public transportation. I think that's the model we'll end up with, not even the current automotive model, and the automotive industry will completely change, in my view. Did Walmart change retail or Amazon? Did Boeing and Lockheed change space or SpaceX? I could go on and on. Did NBC or CBS change media, or YouTube and Twitter and Facebook? So it's hard to think of a large innovation. The answer to your question, a few will adapt it later. Though the macro characteristics make sense from an economic sense, the cost to an individual making that micro decision in a company is too high if they're wrong. And innovation depends on ability and willingness to fail. And because of that, big companies can never lead. That's a whole long discussion. So I only look at non-institutional approaches to change as opposed to any kind of institutional approach. And Trump was an example. You know, I know John Podesta well. He ran the campaign like a political expert would. And there was this other thing, Twitter mainly, that was used to change all the assumptions of a traditional campaign. So yes, some will adapt it a little bit later. I think the bigger companies are getting better at following the startups more and giving more credibility now, and believing there's massive disruption. John Deere bought this company because they believed they could do more with this in farming than they could without it. I'm sorry. I'll try and go a little bit faster because I can go on any of these topics for a long time.
We have about 7 minutes.
Let me suggest two occupations to watch. One is translation, and the other is transcription, where we already have really quite advanced capabilities. But in my view, initially, you're going to see employment in those areas increase because the computerized translation and transcription can be a first run that the human then polishes. So we end up with lower prices, more translation, more transcription being done. In the long run, we think that they would take over pretty much completely, but for the short-term future, you would expect to see this happen. Now, we can watch the data for the next 20 years and see what happens to translation
I
and
think you're
transcription.
exactly right. And in our AI lingo, we'd say the humans are training the AI to get better enough to supersede them. Yes?
I need to ask you this question. You know, my microphone started talking. Sorry. So, Mr. Khosla, would you mind telling me one thing, just one thing, that you think people really will be able to do better than machines forever? Look, I mean, you
I've
showed us.
thought,
Let me
I've thought
say-
about it, Howard. I thought the emotional connection would be the most important variable. But some of the research shows that patients are much more honest with machines than with doctors. They disclose more data. How much have you been drinking? Way more accurate data when a machine asks than when a doctor asks.
Fair enough. But look, it's possible that an AI machine can write music that we would not be able to recognize from the real Mozart. But before Mozart, there was no Mozart. Will a machine be able to create not a fake of Mozart, but something that will be as new as Mozart was to music in the 18th century?
I have very little doubt the answer is yes. What I don't know is when. Okay? Almost, and that's why I had that example about synthesizing a new instrument, because it'll allow a range of capability, a set of tools for the machine to use that may be hard for, and the more complexity, the more you can do. The purpose of music is really to resonate with the human brain. I actually believe, and I've seen startups that are trying to compose music for each person's individual brain, not for 7 billion people, because each of our brains is wired differently. We might respond differently. And so the ideal song for us may be a little different than a generic song. Yes? Oh, okay. Hi, Eric.
Hi. So, love your talk. I want to flesh out have you flesh out a little bit the point about replaceable but not replaced. And you invest not just in technologies, but business models. So you know that it takes a while for the companies, the ecosystem, the customers to adapt. So can you just walk through a little bit more what you see the timeline? Let's take one of your examples, like you showed that killer robot, the one that kills the plants, not the humans. Yeah. And you said John Deere bought it. It's working now. How do you see the timeline working for that to be adopted by, say, a majority of farmers in the United States?
Yeah, I'm glad you brought that up. So you do this fairly narrowly because farmers are conservative. They generally have debt outstanding and they can't afford a bad crop season. They go under. We'll first introduce this so we did this first in lettuce, which is a small crop. We've done hundreds of thousands of acres of fields, but it's a very tiny business, wouldn't show up in any numbers. Next thing we're doing is weeding in cotton. Why? Because herbicide resistance in cotton is growing very rapidly. And so there's an urgent need beyond just cost savings. After cotton, we'll do corn. Lettuce is very easy to do because it's $3,000 of economic value per acre per year. Cotton is less, corn is even less, and as the technology gets better, so there's a natural cycle. So if you imagine, and if you read my medicine paper, I imagine a new version of a technology in a particular area every 3 years as the development cycle for a new capability. And so if you take 7 doublings, 7 of these improvements, you sort of get to the timelines. If it's 7 times 3, 20 years is a rough estimate. And I used, in my paper on medicine, I used the analogy, my first cell phone was about the size of a sewing machine that took up the whole passenger side. That was version 0. And then there was this brick, that Motorola iconic brick. And then there was the flip phone, and then there was the Motorola StarTrack, and then there was the BlackBerry, and then the iPhone. You walk through these generations and say, that's a reasonable proxy. That's why I call everything I say speculation, not prediction. But that's sort of my guess.
I think I heard the number 20 years in there. Is that sort of, yeah.
I sort of say 7 cycles of innovation before it gets good enough. Okay.
So I share your views that we humans will probably become less efficient at every task, at every job, compared to machines or artificial intelligence.
The way I like to think about it, will work if we want to work, not if we need to work.
Right, and I guess that includes economics and venture capitalism and so on at some point. Now, what interventions do you see that we as humanity can engage in to ensure that we will, let's say, not be outcompeted and basically disappear from Earth?
Yeah. Well, I don't know the answer to that. Imagine the following. If per capita average income was $300,000 in this country, how you'd look at the question of redistribution. Whether it's minimum income, whether it's some sort of structure that doesn't lose the incentive to work. There's lots of these sort of issues. I can come up with many universal basic income or other mechanisms that preserve the incentive to work. The transition is hard to predict, but you don't get to 300,000 average income, and I use average, not median, because it will be very lopsided. How we do it and what influence democracy has on it, because capitalism doesn't work without democratic permission. That's the piece that's so hard to predict. Last question. Yes.
I was just asking about your point on inequality. So going back to Ricardo in 1810s, that we know the fixed factor earns the rent. So to the extent that inequality grows, there must be some fixed factor to earn the rents, and whether, say, owning artificial intelligence algorithms or data sets or whatever is a fixed factor or something that's copyable and super competitive is the result of policy choices we make. And so I find it, I just don't even know how we could predict what the result of AI and inequality is going to be unless we have some sort of insight into, if you look at, say, agriculture, you showed us the graph of the enormous productivity improvements in agriculture in the early 20th century. And, the owners of the tractors and the farmland didn't become our major business titans, right? Just the returns to agriculture, and they went to zero because of the super competitive industry. And one can imagine the same thing happening with AI. When it becomes commoditized, we have massive productivity improvement, and the returns all go to, say, people making compliments or people who have high income elasticity of demand to make custom cabinets or whatever. So I just find this sort of assumption that the return on capital in a competitive industry will remain where it is today in a non-competitive industry. It's just an odd assumption to make about what's going to happen in the future.
Look, it's very hard to speculate. There is very asymmetric development going on. By and large, in the US, most AI research is open source. In parts of the world, it is not. In fact, the amount of, for example, Chinese investment in AI in Silicon Valley is going through the roof, either directly or surreptitiously. We see this all the time. And that's where the asymmetric, what's yours is ours, and what's mine is mine, kind of approach to life worries me. There's another aspect of it that is different than other technologies. Nuclear treaties work because there was verifiability. You could verify a nuclear explosion. There was no way for North Korea to hide an explosion. In AI, you may not have verifiability. Most technologies become visible when they come to market, but if you have no notion of what's behind the screen, which is likely to be the case with AI, it creates a whole set of other problems, both in regulation and in because of verifiability and all that. Thank you all very much.